Assalamualaikum and good days everyone. So I'm going to give you a lecture about the partial differential equation. So right now I'm going to teach you how to solve the PDE. So we have learned there are three important PDE, the partial differential equations. The first one is wave equation. Second one is heat equation and Laplace equation. Okay, so these are the formula for the equations. So make sure you notice this, understand this equation. What is the upside down triangle? So that is the habla, and habla square is equal to this formula. Okay, and this is for 3D. And for 2D and 1D, you just eliminate the Z component or both Z and Y component for 1D. Okay, so these are the solution. Now we go to the solution. So for the first one is the solution of wave equation. So if you go to the section 9.3, you can see how this is derived, this formula derived, but I won't teach you how to derive this formula, but you can use this formula to solve the wave equation in an example or in question. Okay, so if you look at compare this equation, this formula with this, you can see that there is C component right here. So C is this C is related to this C. Okay, and now we go to the next formula, which is the solution of heat equation. So these are the solution of heat equation. So if you look at here, you can you are familiar with this form of equation, where we have exponential, we have sine and cos. Like so, this is if you remember clearly, it is related to ODE, ordinary differential equation, where since both are differential equation, they are related. So for the heat equation, these are the solution. So it has similar form like ODE. And when we expand it, and when we consider all boundary condition, so like I said before, in PDE, boundary condition is very important in solving PDE. So if we don't have any boundary condition, it will be difficult to solve a PDE. So we will use boundary condition to solve PDE. So when we consider all boundary condition, so when there is a multiple boundary condition, we need to sum all the solution, and we will have this formula. So this is the sigma is the symbol of summation. So this is the same with n index. So n is the number of boundary condition. Okay, that is the solution for heat equation. Now we go to the solution of Laplace equation. So Laplace equation, again, this is the simple formula for the Laplace equation. So in this solution, we have lambda. We have lambda, and the solution depends on the value of lambda. So what is lambda? So when we consider this form of solution, the final answer that has this form, we have a function of big X and yx. So when we relate with the equation, we can see that 1 over big X and the big X second derivative with respect to X is equal to lambda. And when 1 over Y, big Y, second derivative of big Y, and this one is negative, it will be equal to lambda, and this lambda is similar. So that is the lambda that we want to find. And after we find the lambda, then we can decide which formula we will choose. Actually, there is 5 equations for the solution of Laplace equations. So you can refer to the advanced mathematics book. So go to equation 9.52 A to E. So that is the equation that you need to remember. You don't have to memorize it, but you need to understand it. Okay, so each of these equations depends on the value of lambda. Actually, there is 3 equation. So 3 equation for 3 different value of lambda. Okay, so we need to know the value of lambda first, and then we can choose which equation is suitable for the solution.